Hi folks, it's Cricket again. I wanted to take a few minutes to talk about a feature that we just introduced that I'm really proud of. It's called Local Internet Breakout, and it's particularly important today with more folks working from remote locations and using more and more SaaS services. We've heard from our customers that many of them still backhaul these remote offices to one of their central data centers because they don't feel that they can adequately secure the offices if they use local internet access. But of course, that's expensive, and it probably provides a terrible user experience with all their access to SaaS services hairpinning to the corporate data center and back. Local Internet Breakout allows folks at these remote sites to connect directly and securely to their SaaS provider's closest point of presence and to their corporate network, giving them a much better user experience. But before talking about Local Internet Breakout, I need to give you a little bit of background. First, Infoblox has two SaaS offerings. The first one is BloxOne Threat Defense, which is a cloud-based recursive DNS service. Customers can send queries to our Anycast addresses, and we'll check reputational information and our own analytical algorithms to make sure that neither the name they're looking up nor the data returned is malicious. The other is BloxOne DDI, our cloud-managed DDI service. I've talked about BloxOne DDI a little bit before, but mostly in the context of its DHCP redundancy options. I did show off some of the cloud services portal where you configure your cloud-managed DNS and DHCP servers. You can use BloxOne Threat Defense by configuring your stub resolver to query one of our Anycast addresses directly, or you can load our endpoint software on your client, or you can run our DNS forwarding proxy on your network and let clients use that. And of course, you can configure your BloxOne DDI DNS servers to forward queries to our Anycast addresses. And it's this last option that we're the most interested in today. There's currently a challenge with using cloud-based secure recursive DNS services, or in fact any central DNS servers from your local DNS servers. When you look up a domain name for the first time using DNS, your DNS server usually has to query one or more authoritative DNS servers on the internet to get the answer. And nowadays, some of those authoritative DNS servers will return an answer that is tailored to your DNS server. And what I mean by that is that the answer returned, maybe it's an IP address, it's selected because it's close to your DNS server. So if your DNS server is here in the Bay Area and you look up the domain name of some content hosted by some content delivery network, they will try to return an IP address that's also in the Bay Area that can serve that content. There are lots of different names for this. Geolocation, geographic routing, for example. And when it works, it really helps improve your experience on the internet. Imagine if the content is a 2-hour movie you want to stream. There's a big difference between streaming it from a cache close to you and one that's across the country. The problem is when your DNS server forwards to a big central DNS service in the cloud or at your corporate office. While we try to offer DNS services from as many points of presence as we can, the DNS server you query may not be as close to your DNS server or to the client as we would like, and you may get a less than optimal response. So here's a diagram that shows the way that works. We have a remote office down at the bottom, a stub resolver querying a local recursive name server at 10.0.1.1, and it's forwarding up to this cloud-based recursive DNS service. So the stub resolver sends a query, local recursive DNS server forwards that to the cloud-based recursive DNS service, and now the cloud-based recursive DNS service is going to query one of those authoritative DNS servers along the top on our behalf. But now the authoritative DNS server needs to make some sort of a response as to how to respond, which IP address, for example, to respond with, based on what the source IP address it got it from, which is just an IP address that's owned by the recursive DNS service, not necessarily something related to the local recursive DNS server. Now, it would be really nice if our central DNS service could simply tell the authoritative DNS servers that it queries the IP address of the DNS server on whose behalf it's looking up a domain name. And in fact, it can using a relatively new extension to DNS called eDNS Client Subnet. This diagram shows the way that eDNS Client Subnet is supposed to work. So now the stub resolver down at the remote office is going to query the local recursive DNS server. Local recursive DNS server forwards that to the cloud-based recursive DNS service, and the cloud-based recursive DNS service queries the authoritative DNS server at the top. But it includes a special eDNS option, client subnet, which says, I am conducting this query on behalf of a DNS server that is on the subnet 10.0.1/24. So now the authoritative DNS server can respond based on that information. It can tailor its response to the original querier. That sounds great, right? The problem is that it really doesn't work very well because there are a lot of organizations, a lot of SaaS providers out there who don't support it on their authoritative DNS servers. In particular, there's this outfit in Redmond, Washington that doesn't support it. And wouldn't you still like to get to the closest Office 365 or Exchange server in the cloud? In cases like this, it would be better to have your local DNS server down at the bottom do all the resolution because it would get a better answer, one tailored for it. But we still want to check that the query and the answer aren't malicious. So how do we do that? Here's where the cool tech comes in. Since Bind 9.12, Bind has supported something called an RPS hook. RPS stands for Response Policy Service, and the RPS hook lets Bind talk to some other process to determine what to do with a query or a response. So here's how the Bind DNS server in BloxOne DDI uses it. You can resolve most domain names using BloxOne Threat Defense and keep a list of exceptional domain names that you need to have resolved locally, and the RPS hook will let Bind know which those are. Or if you prefer, you can configure Bind to resolve everything locally and just use the RPS hook to check whether or not the query and the response are malicious. Here's a diagram that shows how this works. You see we still have the stub resolver at the remote office down here in the lower left. We now have a BloxOne DDI recursive DNS server at the remote office. We fire off a query to the BloxOne DDI recursive DNS server. It checks the RPS hook and it says, should I resolve this locally? And the RPS hook says, yes. Then it fires off a query directly to one of those authoritative DNS servers at the top of the slide. It gets a response back. But before returning that response to the stub resolver, it sends the query and the response off to BloxOne Threat Defense to say, is this safe? And if BloxOne Threat Defense says yes, then it can relay that to the original querier. So you get the best of both worlds. You get local internet resolution, local breakout, and you still get a solid, safe response that's returned. So now let's go on to doing a demo of how this works within the Cloud Services portal.